Hello students, in this video we'll see how to resolve a vector and how to multiply two or more vectors. Resolution of the vector means splitting of vector into two equivalent vectors. Let's consider a vector A. Normally, we split the vector into two components which are mutually perpendicular. Now, suppose you are given a vector A, then its component making angle theta with its direction has a magnitude A cos theta. The component perpendicular to this has a magnitude A sin theta. Next, we will see how to multiply two vectors. When you multiply two vectors, there are two possibilities. It may result into a scalar quantity or it can result into vector quantity. If it results into scalar quantity, then it is called as a scalar product and we write it as vector A dot vector B, and it is also called as dot product, and it is defined as AB cos theta, where theta is the angle between vector A and vector B. This dot product can be given also in terms of the component of the vector. See, vector A has a component Ax, Ay, Az. Vector B has a component Bx, By, Bz, and a dot product can be given as Ax, Bx plus Ay, By plus Az, Bz. A dot product is commutative. That means vector A dot vector B is equal to vector B dot vector A. Now this is what is shown here is the dot product of the unit vectors. See, I dot I is the magnitude of I is 1. So this is 1 and the angle between this I and I is 0. Cos 0 is 1. That's why it is equal to 1. In same way, J dot J is equal to 1 and K dot K is equal to 1. Now I dot J, see, I is along the x-axis, J is along the y-axis, so they are perpendicular to each other. So theta is 90 and cos of 90 is 0. So I dot J or J dot I, J dot K or K dot J and K dot I or I dot K, that is equal to 0. When two vectors are multiplied and it results into another vector quantity, then that multiplication is called as a vector product. So vector A cross vector B is equal to another vector, vector C, whose magnitude is equal to AB sin theta. That means magnitude of A cross B is equal to AB sin theta and not vector A cross vector B equal to AB sin theta. So this is the magnitude. Now let us see what is its direction. The direction of A cross B is perpendicular to both A as well as B. And see, now here vector A and vector B, let us say that this is in one plane. The cross product is perpendicular to both. Now if they are perpendicular to the both, there are two possibilities. Either it is this way or other way. Now actually what is that direction? And that is given by what is called as a right hand term rule. Now let us see how to apply this right hand thumb rule. You have to take the right hand, keep the thumb perpendicular to the plane of vector A and vector B. Now there are two ways of keeping it, thumb this way or thumb this way. Now you should keep this thumb in such a way that the fingers are going from first vector to the second vector. Here from A to B, then the direction of the thumb gives the direction of A cross B. Suppose you want to find out B cross A, so these fingers should curl from B to A, so direction of thumb will be this way, opposite to that vector A cross vector B. So vector A cross vector B equal to minus vector B cross vector A. They have the same magnitude but directions are opposite. Then the cross product of the unit vectors I cross I, so angle between the same vector is 0, so sine 0 is 0, so that's why the cross product is 0. Then I cross J, see I cross J, the angle is 90 degrees, sine 90 is 1 and the magnitude of I cap is 1, J cap is 1. So it is the value here is 1, but direction of that you can find using the right hand thumb rule, and if you use it you will find that it is along the positive z axis, that's why it is k cap. Similarly J cap cross k cap equal to I cap and k cross I cap equal to j cap. So it is cyclic. So if you say ijk, I cross j equal to k, then if you go from j to k, that j cross k equal to I, then you go from k to I, that is k cross I equal to j. Now if you reverse this, if you take j cross I, then it will be minus k cross j, then minus I cross k equal to minus j. The A cross B can be found using the components of A and B, and one can find that cross product by evaluating a 3 by 3 determinant. See, there are 3 rows here and 3 columns. In first row, the coefficients are unit vectors I cap, j cap and k cap. In the second row, these are the components of the first vector. Then third row is the component of the second vector. So first we should know how to write this 3 by 3 determinant. Then convert this 3 by 3 determinant into 2 by 2 determinant. Now here the multiple of this 2 by 2 determinant are the coefficient of the first row with the sign alternate. So here multiplier plus I cap minus j cap plus k cap. Then to get the 2 by 2 determinant whose multiple is I cap is, you cover the row and the column containing I cap. So whatever return remains here, right in that order, you will get the 2 by 2 determinant. To get the 2 by 2 determinant whose multiple is j cap, you cover the row and column containing j cap. Whatever remains here should be written in the 2 by 2 determinant. Then to get the components, coefficient of this 2 by 2 determinant whose multiple is k cap, cover the row and the column containing k cap, and whatever remains here, it is to be written as a coefficient of 2 by 2 determinant. Then from here you will calculate this value of the 2 by 2 determinant. The value of the 2 by 2 determinant is, you multiply the diagonals and subtract. So this into this minus this into this. So what you get is AY BZ minus AZ BY. Similarly here AX BZ and AZ BX. Similarly here AX BY and AY BX. So this is the formula for the cross product. Next is to multiply 3 vectors, and it is called as a triple product. When the 3 vectors are multiplied, it may result into scalar quantity, and it is called as a scalar triple product, or it may result into vector quantity. It is called as a vector triple product. Now first one, a scalar triple product. So in this case A, B, C, these are 3 vectors. So first you find that B cross C, there is a vector quantity, and then take the dot product with vector A. So this is a scalar triple product. Here see, this is a vector, this is vectors, and when you take a dot product, it is a scalar quantity. So resulting quantity is a scalar. Now this A dot B cross C is equal to B dot C cross A and equal to C dot A cross B. Again it is cyclic, A, B, C. So it is a cyclic, and there is a formula to evaluate it by using 3 by 3 determinant. The first row, they are component of the first vector, second row components of the second vector, and third row are the component of the third vector. Then the second type of the triple product is vector triple product. That means resulting quantity is a vector quantity. So A cross B cross C. So find out B cross C. Then you take a cross product of that with A. Now this is to be written in the proper order because the cross product is not commutative, and also you have to put a proper bracket. So when you put a bracket here means you have to take a cross product of B and C. Then afterwards you take a cross product of A with this resulting vector. There is no formula for this like the scalar triple product, but we have to evaluate it. Find B cross C by using the 3 by 3 determinant, and again use find the cross product of this by again using the 3 by 3 determinant. But there is some transformation here. A cross B cross C can be written as vector B, vector A dot vector C, then vector C, vector A dot vector B. Now this is a scalar quantity. So what remains here is a vector. This is a scalar quantity. So what remains here is a vector.